Hey guys, it's Mr. Schmidt here, and in this video, we're going to start Unit 3 Production, Cost, and the Perfect Competition Model. This unit, along with Unit 4, are perhaps the two most important units in the AP Microeconomics course because we're going to develop two very important graphs. One is called Perfect Competition, the other is called Monopoly. Monopoly will deal with in Unit 4. Really, units 3 and 4 are building off of what we've done in unit 2. Unit 2 is really about, well, what is a market? How does a market work? Units 3 and 4 are, how do firms participate in markets? How do they determine how much of their product they're going to produce at what price to make a profit? And so in this unit, we're going to look at one of the two biggest types of firms, which is perfect competition. But we're going to start here with topic 3.1, which is called the production function. So remember, we talked in Unit 1 that inputs are another word for resources. And one thing that I didn't mention when we originally talked about resources was that they can either be fixed or variable. A fixed resource is a resource that doesn't change with the output produced. So no matter how much output I produce, I have the same number of this resource. So for example, maybe there's a situation where I'm making a product and I only have one table to make the product, or I only have one pair of scissors to make the product, and it doesn't matter how much the output I'm making. That's an example of a fixed resource. A variable resource is a resource that does change with the output produced. And the classic example here is workers, right? As a firm, as a company, a business, I can change how many workers I hire, and I often will scale that amount of workers with the amount of output I'm producing. So in other words, yes, the output's producing, or the output I'm producing is increasing, but also the amount of resources I'm using are increasing. So, as a point of practice, I want you to pause the video and identify one fixed resource and one variable resource used to make pizza. So, there's a lot of correct answers you could have given here, but one example of fixed resource here would be a pizza oven. So, you have a limited number of pizza ovens, doesn't matter how much output you produce. And again, workers would be a great example of a variable resource. So now that we've talked about input, let's talk about the output. Production is the connective tissue between the two. Production is the process by which inputs are turned into outputs. That output can often be called total or total physical product. This is also what we refer to as the production function. Kind of sounds like something out of Schoolhouse Rock instead of conjunction junction. Is that what you call it? I don't know. But instead of that, it's production function. But total product is also abbreviated as TP or TPP, or, and you might be familiar with this one, Q for quantity. So quantity is the same thing as total product. So for a marginal product or marginal physical product, again, we're going to introduce that word marginal. We've talked about this word already. Remember, we talked about marginal utility, marginal benefit, marginal cost. It's coming back again here. And it is the change in output when an additional resource, typically labor, is added. So if I increase my number of workers by one, how much will my output change? Either an increase or a decrease, because yes, marginal product can be negative. It is the change in total product, and we typically abbreviate it as MP or MPP, marginal physical product. And so we've got a graph here of total product. And this is going to look very familiar to you because this is the exact shape of total utility we did back in Unit 1, except now we have labor for the horizontal axis and total product for the vertical axis. And what you see here is that at first total product's pretty steep. Marginal product is increasing, and then it eventually decreases. Marginal product eventually becomes zero, and then it becomes negative, right? So what explains this shape? What explains how it gets flatter and flatter, total product that is, and it starts to become negative? Well, the answer is the law of diminishing marginal product, which should sound familiar, just like the law of diminishing marginal utility. It says that as variable resources are added to fixed resources, the additional output from each additional resource will eventually fall. A great example of this, if you've ever seen the movie Ratatouille, it's a animated film by Pixar. In the film, it basically goes through what life is like in a French kitchen, a very high scale, upper class French kitchen. And all these cooks are doing their thing right. And then here comes Linguini, this scrawny, kind of a screw up of a guy, and he kind of messes everything up. Well, that's kind of the idea of the law of diminishing marginal product or the law of diminishing marginal utility. It's this idea that, at first when you start a restaurant and you're adding workers, boy, each worker adds a lot to your product. But eventually, what happens here is that you get to a number of workers where instead of helping you, they start to hurt you because they have either nothing to do or you've run out of good workers to hire, and now all you have are incompetent ones like Linguini. And so the lesson for the firm is you kind of want to stop hiring, when these workers really aren't giving you any additional benefit or product. And then finally, let's talk about average product. It's how much, on average, each variable resource, typically labor, is contributing to total product. Think of it as the product or the output per worker, and it's calculated as total product divided by labor. And so the last thing I want to do before a quick practice question is putting average product and marginal product on the same graph, because there's an interesting relationship between the two. So you notice here we have labor and then we have our products on the y-axis. You notice this intersection point, right? When average product is maximized, that is where it's intersecting marginal product. Now, what explains this relationship? Well, I want you to think about it in terms of your grades, right? Think of average product as your grade in the class, and think of marginal product as your grade on one individual exam. So if you do well on an exam, the red here, it's going up, that's pulling your average up in the class, right? But if you start to do bad as marginal product goes down, or your grade on one assignment goes down, it's pulling your average down, right? So the marginal is either pulling the average up or it's pulling the average down. And then finally, go ahead and pause the video, take a look at this practice question, and then we'll look at the answer. So the correct answer here is D. It is less than the marginal product of the third worker due to diminishing returns. So it says, based on the production data, which of the following statements about the marginal product of the fifth worker is true? And what you notice here is it goes up 4, 5, 6, 6, and then down to 4. So we're starting to see that diminishing, or sorry, good grief, 4, 5, plus 4, plus 5, plus 6, plus 5, then plus 4. I'm sorry for my math. But you're starting to see that around that third worker, we start to see those diminishing returns set in, and marginal product is decreasing. Now, total product, which is the numbers you see in the table, are still increasing, but marginal product is pulling that, is starting to take effect and making total product increase at a decreasing rate. So that's all for this video on the production function. Until next time, have a great day.